Hi everyone. I'll just start now. I'll just share my screen. Please tell if the screen is visible or not.
Screen is not visible.
Yeah, just a second. I'm just sharing. Screen visible?
Yes, sir. Now visual.
Okay. Thanks. We'll just start. It's now 6:07 almost. So I think you can start. Okay. So in the last class, in the last tutorial sessions, we left off with RC circuits, right? RC and RL circuits, basically first order circuits, right? We saw some problems. Okay. So in today's session, we will be solving problems on AC circuits. Okay. So mm, the yeah, just one problem is left in the RC network, and after that we can go towards AC circuits. Okay, fine. So the first problem is the switch in figure opens at t equal to 0. Find V naught for t more than 0. Okay. So the graph is the circuit is something like this. 2 kilo ohms. This is 3 millifarad. Okay. And the switch is opening at t equal to 0. Find V naught is a question. Okay. So for this question, they have also given us some options. That is 10 e power minus 12t, 10 e power minus 0.0833t, then 15 e power minus 12t, then 15 e power minus 0.0833t. Okay. So without solving, can anyone tell the answer? Can you try without solving? Without taking our pen, I want to find out the answer. Okay. So can anyone try? Okay, so see over here.
The B1, option B.
Answer is option B. Correct. How do you tell?
Sir, the supply has 15 volts and some voltage
Correct.
will drop across 2 kilo ohm. Therefore, the 15 C and D option will not be the answer.
Sure. Hmm.
Also, the time constant is 4 into 3 means 12 something. And in the A
Correct.
option, it is multiplied with T. But in B option, it will be divided. Therefore, A is not the option. Only B option is remained.
Correct. Perfect. Perfect. So basically, first of all, under steady state, you're right. So under steady state, when the switch was closed, right? Under steady state, when t less than 0, correct? In that case, your capital V naught, right? I'm writing capital V naught to indicate steady state. So your capital V naught will be how much? 15 into 4K divided by 4K plus 2K, right? Which will give you 15 into 4 by 6 or 15 into 2 by 3, which is 10 volts. So obviously C and D are eliminated. Okay. So you understand that under steady state, the capacitor acts as a open circuit, correct? So under steady state, once you tell steady state, 3 millifarad capacitor acts as an open circuit. Okay. Therefore, capacitor cannot be considered. Therefore, you just have a 15 volt and a potential division 2K and 4K, right? That is, you have something like 15 volt and then 2K. The switch is closed over here and there is 4K. So you see the output across this because capacitor is open. This will be your V naught, capital V naught. Okay. So now there is no other active source. Once the switch is opened, what happens? The active source is kind of disconnected. Okay. So after t more than 0, what happens? Your switch is disconnected. There is no active source. Therefore, you only have the 4K resistor and there is a charged capacitor, right? There is a charged capacitor of 3 millifarad. Okay. There is also a charge of V naught, right? So what is your time constant? Time constant is R into C, which is in our case, the time constant is going to be 4K into 3 millifarad, right? Kilo and milli cancel out, therefore it will give you 12 seconds. This is the time constant. So now what is the output voltage? Your output voltage, you know, V naught is equal to capital V into e power minus t by tau, right? So capital V is 10 and e power minus t by 12. This is your answer. T by 12, 1 by 12 is 0.0833. Okay. So directly by inspection, you can write the answer or you can also solve it. Okay. Okay. So this was a simple problem. Okay. So we will go ahead with the next question. So now we are going to AC circuits. So for a single phase AC circuit, for a single phase, I'm writing single phase like this, but this is actually for a single phase AC circuit. With equivalent Okay. Equivalent impedance so current leads voltage by 90°. Current leads voltage by 45°. Current lags voltage by 45°, and current lags voltage by 30°. So again, by inspection, can you try? What will be the answer for this question? So the impedance is given. Okay. The impedance of the circuit is 2 minus 2j ohms. Okay. This is the impedance. So what is the answer for this question? Anyone? Okay. So let's assume a circuit, right? They have given a single phase AC circuit. So you take a voltage source V, right? And you are connecting it across an impedance. Okay. I have an impedance over here. So this impedance is Z, which is 2 minus 2j ohms. Okay. And I have a current that flows because of this voltage source. Okay. The point is, what is the relation between the voltage and current? What is the angle between voltage and current? What is the relation? Okay. So you would have studied that in any RLC circuit, right? In any RLC network, what you have is basically Z is equal to what? R, this is the real term, plus J into XL, which is the inductive impedance, and minus J into XC, right? This is the capacitive impedance. So therefore you get R plus J into XL minus XC. Okay. So you obviously understand R is the real part and XL minus XC is the imaginary part. Okay. So now if XL more than XC, right? Your net impedance will be what? R plus J X, right? If XL is more than XC, right? So over here, which is dominating? If Z is equal to R plus JX, over here, since X is positive, you see that your inductive impedance is dominating. So the circuit can be said to be inductive. Okay. If a circuit is inductive, you would know that current lags voltage, right? On the other hand, if XL is less than XC, then that is XC is greater than XL, you would know that Z is equal to R minus JX, right? Because it would be a negative number. XL minus XC would be negative, right? So the circuit now becomes predominantly capacitive. Okay, predominantly capacitive. Therefore, current leads voltage. So from this analogy, can you tell whether our current is leading or lagging? Our circuit is inductive or capacitive?
It's a capacitive circuit.
Correct. It's a capacitive circuit. So either the answer is A or B, right? Definitely current is going to lead voltage. Okay. Fine. So now the point is, what is the phase angle? Your phase angle is going to be what? It's going to be tan inverse X by R. Correct? Correct. So it is tan inverse X by R. Okay. Over here, what is X? Z is 2 minus 2j omega. Z is 2 minus 2j, right? Ohms. So you understand tan inverse X part is basically minus 2 and this is 2, right? So tan inverse minus 1, which is 45 degrees or minus 45 degrees, correct? So the negative sign indicates that current is basically leading the voltage or voltage lags the current. Okay. So tan inverse 1 is obviously 45 degrees. Therefore, you see that the answer is going to be option A. Option B. Current leads the voltage by 45 degrees. Is it understood? This is fine, right?
Yes, sir.
Okay. And of course, if I can somehow compensate, if I make XL equal to XC, right? Then your Z will be R plus J into XL minus XC, which will simply be R because XL and XC cancel out. Okay. So the circuit is said to be predominantly resistive. Current and voltage are in phase. This is something that you guys all know, right? Okay. So we will move on to the next question. The power dissipated in a circuit will be 0 when the phase difference between the current and voltage is dash. So when will the power dissipated be 0, right? That is, there is no I square R loss, right? Power dissipated is what you would know. The power dissipated is basically I square R, right? So when would that be 0? For what phase angle? 90 degree, 180 degree, and 45 degree. So when would the power be 0?
At 90 degrees.
Why?
So because the power factor is 0.
Correct. So the option is why? Because the reason is that if you tell that the angle is 90 degree, right? If you tell that the angle is 90 degree, you understand that the power factor or cos phi will be 0. So if you tell that cos phi is 0, you know that power is equal to what? Power is equal to S into cos phi, where S is your apparent power, right? So you would know that S is equal to P plus JQ, right? Where P is your real power and Q is your reactive power. So S is your apparent power. So basically the real part is S cos phi, right? As we all know. Cos theta plus j sin theta, right? So S cos phi, that's your real power. So if your cos phi is 0, it means that S into anything, S into 0 is just going to be 0 directly. So this would happen only if your phase angle is 90 degree. Okay. So again, it means that the entire power is reactive power. It can either be positive or negative depending on whether the circuit is inductive or capacitive. But the point is that it's going to be entirely reactive power that's flowing in the circuit. Okay. So only reactive power flows. Okay. We'll move on to the next question. Find the amplitude in volts, phase in degree, period in seconds, and frequency. Of the sinusoid. Okay. So the given sinusoid is V of t is equal to P25.6 cos P14 t plus 120 degree volts. Okay. So this is the sinusoid. So we have to find out the amplitude, phase, period, and frequency. So the options are P25.6, 120 degree, 314, 314 seconds, 3 hertz, right? 230 volts, 120 degree, 0.02 seconds, 50 hertz. C is 325.6 volts, 120 degree, 0.02 second, 314 hertz. What is the answer directly? So a sinusoid is given, some waveform is given. Just you need to determine the amplitude, the phase, period, and the frequency. So how would you find out?
Option B.
What is the option?
D.
Option B or option D?
D. D for dog.
Correct. So the generic form, as you would know, is basically what? V is equal to amplitude A, cos or sine doesn't matter, then cos omega t plus pi, right? Where omega is equal to 2 pi into f. This is in radians per second, correct? So this you can do the analogy over here. Therefore, your amplitude is directly T25.6 volts. Okay. And your omega is basically 314 radians per second, which means that F is equal to omega by 2 pi. So 314 by 2 pi would give you 50 hertz, right? Directly. So this is done, omega is done, and of course phase is 120-degree. Okay, direct answer. Just by looking, you can guess the answer, right? Okay, so I think this is also pretty easy. We will move on to the next question. Okay, so the question is,
Sir,
yeah,
I haven't done. In
haha,
the
tell,
previous
please.
question, all the phase angles are given 120-degree.
Correct.
But if the angle is in the options, all the phase angles are not equal. So then, do we have to convert cos function into sine and then give the answer of the phase angle?
No, no, no. See, cos or sine is basically our convention only, right? Correct.
Okay.
So
Okay.
the point is that if let's say you take voltage also in cos, this is an isolated question over here, just V of t is given. But generally, if they give both voltage and current, we are not concerned about whether it is cos or sine. We are concerned about the phase difference. So if voltage is cos and current is in sine, then you understand directly that there is a difference of 90 degrees. The difference is what you need to account for.
Okay,
Okay.
sir. Okay. Okay.
Because you will see in multiple places people use cos as a convention. Okay, generally we study like AC input voltages in terms of sine waves, but cos is also just a phase shifted sine wave, right? So people use cos also as a convention. It's not a problem. So I1 of t is given as 15 cos omega t minus 11. Okay, and I2 of t is 14 sine omega t plus 10. This is also in amperes. This is also in amperes. Okay. So these are two given sinusoids. Find their difference. Answer in polar form. Okay. So you have 23.906 angle. Sixteen point 446 angle 12.293 angle 10.92 ampere. So they have given you two sinusoids and note that one of them is in cos, one of them is in sine. So you have to consider 90-degree phase shift between them. Okay. Okay. So basically we know that cos will lead sine by 90 degrees, correct? Cos is going to lead sine by 90 degrees. That is something we know. So I can write 15 cos omega t minus 11 as 15 sine omega t minus 11 plus 90 degree, correct? So that is something we already know, right? Okay. So we have to write this in polar form, correct? Answer should be in polar form. So how do we do this? How do we approach? Any guesses? How do we approach this problem? Okay. No, it's so what is I1 of t? I1 of t is 15 cos omega t minus 11, right? So cos a minus b can be written as what? What is cos a minus b? What is cos of a minus b? Cos a cos b plus sin a sin b divided by 2, correct? Is this fine?
So why divide by 2?
Yes, Adi?
Why we
Okay, okay.
divide by 2?
Okay. Understand. Okay, so cos A cos B plus sin A sin B. All right. Okay, so just use your calculators. We have to simplify this particular expression. Hmm. So what would you get? Cos 11 is 0.98 into 50. So 14.724 cos omega t plus 2.862 sin omega t, right? This is one. The I2 of t again we can simplify. So what was I2 of t? I2 of t was I 14 sin omega t plus 10, right? Right. So this can be written as sin of a plus b is basically what? Sin, okay,
Sin cos
sin.
B plus cos A sin B.
Hmm, hmm. So sin omega t into cos 10 plus cos omega t sine 10, correct? So your constant turns out to be 0.984 into 14 is 13.787 sine omega t, and sine 10 into 14 2.431 cos omega t. Okay, so now we have got I1 of t, we have got I2 of t. We just need to find out the difference, right? That was the question. I1 of t minus I2 of t. Okay, so we will take the cost terms together. So 14.724 minus 2.431, correct? So this gives you 12.293. 12.293 cos omega t, and then you have I1 minus I2 is what we are writing. Okay, so then you have 2.862 minus 13.787. $10.925 sin omega t, correct? So this is my difference. So now can anyone tell how do we write this in polar form? How do we write this in polar form? Anyone? Okay. See, if we have to write this in polar form, right? So what do we do? If I have to write it in polar form, I have to write it as some r and then cos or whatever it is, cos omega t plus phi. This is what I want finally, correct? So what do I do? Then I can write, if this is what I want, I can write this as r into cos omega t cos phi minus sin omega t sin phi, right? Now you can compare with the identity, right? This and this can be compared, correct? Correct. So from this, we can directly write that my R is going to be what? My R, so your R cos phi is basically 12.293. R sin phi is basically minus 10.925, right? This is my R cos theta and this is my R sin theta. So in order to find out the magnitude, what do we do? My magnitude will be directly 12.293 square plus 10.925 square. Okay. So how much do we get? I'm getting around 16.45. This is my magnitude. Okay. And what about the phase? Phase angle? Or let me take a different notation over here. So my phase angle theta will be tan inverse the sine part divided by cos part, that is minus 10.925 divided by 12.293, right? So this would give me how much? 10.925 divided by 12.293. So tan inverse answer. Yeah. So I'm getting 41.628. Okay. So let's check. Yes. So this is the answer. So they have asked for the difference. They have not given whether I1 minus I2 or I2 minus I1. So if you consider I2 minus I1, you will get positive degree. And here we have considered I1 minus I2. That's why we are getting a negative sign over here. Minus 41.628. Okay. Got this right? That
Okay,
is
sir.
basically we converted both of these into rectangular form. We converted both of these in rectangular form, and then we subtracted it, then we converted it back to polar form. Okay.
Okay, sir.
Yes, sir.
Okay. So r angle theta, right? There are multiple ways of doing this. Okay. This was one, that is we just used the identities directly and then we converted and so on. Okay. Obviously, there are multiple ways of doing this problem. Okay, so we will move on to the next question. So based on polar to rectangular conversion, we have a few problems. So okay. So this question was 5. Okay. So the next question will be the apparent power in a single phase AC circuit is S is equal to 5 kVA. The power factor of the circuit is 0.8. Calculate the real and apparent power of the circuit. Okay. So options are 4 kilowatt, 5 kilo volt ampere reactive, 2 kilowatt, 4 kilovolt ampere reactive, 4 kilowatt, 3 kilovolt ampere reactive, and 2.5 kilowatt, 2.5 kilowatt ampere reactive. So this, I think, a very direct question. So can you tell how do you do this? So basically, S is equal to pi kVA, correct? And power factor, which is your cos phi, is 0.8. Okay. So you would know that P is equal to S cos phi. So phi kVA into 0.8, which is 4 kilowatt. Okay. So either A or C. Right. So you also know that Q is equal to S sin phi, right? So if cos phi is 0.8, right? If cos phi is 0.8, what is sin phi? So you know that cos square phi plus sin square phi equal to 1, right? So cos square phi would be 0.8 square plus sin square phi equal to 1. Therefore, sin phi is equal to root over 1 minus 0.8 square, right? That is root over 0.36, which is 0.6. So if cos phi is 0.8, sin phi is 0.6, right? So phi came into 0.6, which is 3 kVAR. Okay, so the answer is C. Okay, I think this was a very easy question.
Okay, sir.
Okay, so we'll go ahead to the next question. Okay. So in a series RL circuit, supply voltage is given as V is equal to 200 root 2 sin omega t volts. And impedance of the circuit is Z is equal to 16 plus J 12 ohms. Calculate reactive power developed in the circuit in kVAR. Okay, so what have they given? They have given voltage is equal to 200 root 2 sin omega t. Z is equal to 16 plus J 12 ohms. Right? So how do we write this? So first we will convert rectangular form to polar form. Okay, 16 plus j12, right? So mod z is going to be root over 16 plus 16 square plus 12 square. What is that? Root over 16 square plus 12 square. It's going to be 20. So this is your polar magnitude. And what about the angle? Theta will be tan inverse imaginary part by real part. So tan inverse 12 by 16, right? So 12 by 16, correct? That happens to be around 36.87 degrees. Okay. So you can write Z is equal to 20 angle 36.87 degrees. Correct? Okay. So from here, we have to find out what is the reactive power. Okay. Okay. So next is what is the current, right? So your I is equal to V by Z, which is 200 root 2 sine omega t. So with sine omega t, I will write this as angle 0, and your Z is going to be 20 angle 36.87. Right? So I can write this as 10 root 2 minus 36.87 degrees. Correct? This is my current in amperes. So once I have got my current, I can write my apparent power is equal to V into I, right? V is 200 root 2 angle 0 multiplied by 10 root 2 angle minus 36.87, right? So I can write this as 200 into 10 is 2000, and root 2 into root 2 is 2, right? And the angle gets added up. So 0 minus 36.87, which is minus 36.87. So this gives you 4000 angle minus 36.87. This is my apparent power in VA, right? So this is my apparent power in VA. Therefore, my reactive power, right? Q is equal to what? Yes, sine phi, right? So magnitude 4000 into sine minus 36.87, right? So this gives you how much? 0.6 into 4000, correct? 4K into 0.6, which gives you 2.4 kilovolt ampere reactive, right? I think if you do it in rectangular form, it will be a little more tedious. So better you convert it to polar form. Okay, I think this was easy. So division is always easy in polar form, as you would know, and but division and multiplication. For addition, you can go for rectangular form. Okay, for addition and subtraction, go with rectangular form, and addition subtraction go with rectangular form, right? A plus JB. Whereas for multiplication or division, go with polar or theta. Okay. Okay, so this is fine. We'll go ahead with the next question. This will be question number 8, right? In a series RLC circuit, R is equal to 12 ohms. XL is 6 ohms. And XC is 9 ohm. So series RLC circuit, R, XL and XC are given. Okay. And the supply voltage RMS value Vs is given as 100 volts. So supply voltage is 100 volts RMS. What is the voltage? Magnitude across the capacitor, right? Okay, so they have given a series RLC circuit. The impedances are given. Supply voltage is also given. What is the voltage developed across the capacitor? So let's take a series RLC circuit first, right? So you have an AC voltage over here. The VRMS is 100 volts, right? There is a resistance whose value is 12 ohms. There is an inductance XL, right? XL is 6 ohms, and there is a capacitor, correct? And capacitor has 9 ohms. They are asking what is the voltage in RMS across the capacitor. What is VC is the question. Okay, so how will you approach this? First point is, while marking your circuit, do not simply write 12 ohm, 6 ohm and 9 ohm. See, this 12 ohm is not the same as this 6 ohms, okay? Because this 12 ohm is an imaginary number, real number, whereas 6 ohm and 9 ohm are imaginary parts. So always write R as 12 ohm, XL should be J6 ohm, right? And XC will be what? XC will be minus J 9 ohms. Agree? Always you should make this distinction clear. Okay, this should be J9, sorry, J6, and this should be minus J9. Okay, always have this distinction, right? Okay, so basically what is your VC? VC will be I into XC, correct? I just need to find out I because I know what is XC they have given. I just need to find out what is I. Okay, what is the current I flowing in the circuit? So seeing this circuit, you can understand I is basically what? V divided by R. Okay. So let's find out the net impedance of the circuit, right? Z is equal to R plus JXL minus JXC, right? So R is 12 plus J6 minus J9. Okay, R plus JXL minus JXC, right? So 12 plus J6 minus J9 or 12 minus J3 ohms. Okay. Since we'll be doing some multiplication division over here, directly convert this into polar form. Okay. So what is this? Mod z? Mod z will be root over 12 square plus 3 square, right? That is how much? 12.34 ohms. Okay. And what is my theta? Tan inverse imaginary part by real part. So which gives you minus 14.04 degree. Okay. So this 12 minus J3, right? So this 12 minus J3. So your Z, right? 12 minus J3 ohms can be written as 12.34 angle minus 14.04. Okay. This is my answer in polar coordinates. All right. So now that I know what is equivalent Z, I can find out the current. So the current is going to be V by Z, which is 200 is what they have given us. Okay, 100, right? 100 volts RMS divided by 12.34 minus 14.04. All right. So this would be how much? So 100 divided by 12.34. 8.1 angle 14.04 amperes. This is my current. So since I know my current, the voltage across the capacitor is basically I into X, right? So VC is equal to I into XC. All right. 8.1 angle 14.04. And what is XC? XC is 9 ohms, right? They just want the magnitude. Okay. They just want the magnitude, right? So directly I can write this is 9, right? And I will neglect the angle. Okay. So I can write that this is 8.1 into 9 ohms. Okay. Which gives me around 73 volts. Okay. Is this fine? Is the question fine? Like, are you able to understand this? So this was a series RLC network, and um, they have given the values of R, XL, and XC, right? So Z is R plus J XL minus J XC. Find out the equivalent impedance in rectangular form. Okay, so this is rectangular form, right? And what we did, we immediately converted rectangular to polar. Okay, we converted rectangular to polar form. So find out Z, find out theta. So your current through the series RLC network is going to be V by Z, right? You find out the magnitude. So what will be your VC? VC will be basically I into XC. That is the voltage across the capacitor will be current into the equivalent impedance. Impedance is 9 ohm and the current is 8.1 amperes. Okay. Okay, I hope this question is clear, right? We will go ahead with the next problem. Am I there or not? Okay, so I'm there. Okay, so the next question is a resistive load rated at 100 volt, 500 watt is to be connected to a capacitor in series connected across a 220 volt 50 hertz supply. Find the phase angle between the current and supply voltage. Okay, so how do we attempt this? They have not given anything about the capacitor, right? So a resistive load rated at 100 volts, 500 watt is to be connected. So they have given the value of the resistance indirectly, right? They have given the voltage and the um, wattage rating, right? Nothing about the capacitor, but they have given the total supply voltage. Okay. So how do we find out the phase angle? How do we find out the phase angle? Let's draw the circuit. Okay. So you understand that there is voltage over here, right? And there is a resistive load and there is also a capacitive network, right? So this is my V supply RMS, right? And let us call the voltage across my resistor. They have given 100 volts, right? Voltage across the resistor is VR. And voltage across the capacitor would be VC, right? So can you apply KVL over here directly? What would be my VC? Just from not numerical numbers, just from this circuit, can we tell what is VC? So you cannot write, you cannot write VC as 100 volts, right? So VC is 100 volts. 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 So VC is Vs is equal to VR plus Vc. Can you write like this directly? Vs is equal to VR plus Vc. Is it possible? Can I write directly Vs is equal to VR plus Vc?
Yes, sir.
Huh?
Yes, sir.
So now you tell, in the previous problem, right? They have given 12 ohm, 6 ohm, and 9 ohm as R, XL, and XC. So Z is equal to, we wrote R plus JXL minus JXC. Why didn't I write 12 plus 6 ohm minus 9 ohm directly? Can I write 12 plus 6 minus 9? Why did I write 12 plus J6 minus J9? You saw this analogy, right? That is, I have over here also in the question, they have not mentioned anywhere it is J6 ohm, J9 ohm and all, right? We kind of knew that impedance offered by the inductor would be J omega, right? And impedance offered omega L. And impedance offered by the capacitor would be minus J by omega C. So that is why we wrote JXL and minus JXC, right? So with this analogy, right? With this analogy, can you tell V is equal to VR plus VC? Can I write directly? Or is it, do I need to have something else? So you cannot write, right? Because Vs and VR would be in phase, whereas Vc would be out of phase, correct? It's a series circuit. Hmm. So you would understand that the voltage, right? The voltage would be kind of over here, it would be phase shifted from VR, right? So this is not correct. The correct representation would be Vs is equal to VR plus JVC. Okay. So magnitude wise, if you see, Vs square is equal to VR square plus Vc square. Therefore, Vc, if you have to find out, it would be root over Vs square minus VR square. Is this clear? Is this understood? Vs is equal to VR plus JVC. Hmm.
Yes, sir.
Got it, right? So you cannot write. Please make sure that you don't add the voltages for resistor and capacitor directly. No, you cannot do that. Okay. So Vc is equal to root over Vs square minus VR square. Just Vs is equal to VR plus JVC. Magnitude wise, if you see, it will just be A plus JB, right? So magnitude would be root over A square plus B square. So from that only we are getting what is Vc. Vc is equal to Vs minus Vs square minus VR square the whole root. This is totally wrong. Okay, please throw it out of your mind if you have such a representation. Okay, please do not make this mistake. Okay, so now let's come back to the problem. They have given VR, right? VR is 100 volts and they have given the supply voltage Vs is 220 volts. So from this, you know what is VR? VR is 100 volts. Vs is 220 volts. Therefore, what would be Vc? So they have given load resistor is connected in series with capacitor across the supply. So your Vc would be root over Vs square minus Vr square. So root over 220 square minus 100 square. Correct? So this would be how much? So you would get 195.96 volts. Okay. This is just the magnitude. Okay. So what about the phase angle? Phase angle would be What about the phase angle? So we have got the magnitude, right? We have got VC, we have got VR. So I can write, since Vs is equal to VR plus JVC. From here I can write tan theta would be imaginary part by real part, VC by VR. Therefore, theta is equal to tan inverse VC is 195.96 divided by VR, they have given 100 volts, right? So tan inverse I am getting around 62.96 degree. Is this question clear? This is a very important question. I would tell it's a tricky question also, right? Don't you would think first see the question, they have given nothing related to capacitor values. They have just given the resistor value, right? They have given the voltage across the resistor and they have given the supply voltage. So Vs is given, Vr is given, Vc is not given. Nothing is given about the capacitor. So you can find out Vc from Vs and Vr. Okay, once you know what is Vc, from the circuit you know that Vs is equal to Vr plus JVC, right? Vs is equal to Vr plus JVC. From this, tan theta is equal to imaginary part by real part. Therefore, theta is just tan inverse of that. Is this question clear to all of you? Please make note of this question. Okay, it's a very tricky question, I would tell. Is this fine?
Yes, sir.
Okay. Just remember this. Vs is equal to Vs plus Vr plus JVC. Okay. So the next question is question number 10. It is a load Z draws 12 kVA at a power factor of 0.8 lagging from a single phase 120 volts RMS 60 hertz AC sinusoidal source. Okay, so they have given the supply voltage, they have given what is the power factor and the apparent power. Calculate this is a simple problem. Calculate the active power kilowatt the reactive power delivered to the load in kilovolt ampere reactive and the peak current. In amperes. Okay. They have given you 4 options. So 9.6 kilowatt, 7.2 kVAR, 141.42 amperes. Then 10 kilowatt, 7.2 kVAR, 100 amperes, 9.6 kilowatt, 'Okay, so so they have given you the apparent power, power factor, and the AC RMS value. Okay. Okay, so let's do this. So this is 12 kVA apparent power. Cos phi is 0.8. Okay. So if cos phi is 0.8, sin phi is root over 1 minus cos square phi, that is 1 minus 0.8 square, which is 0.6, right? This is my sin phi. Okay. So from this, I should directly be able to write, correct? For question number 1, P is equal to S cos phi. So 12 into 0.8, right? That is 12 into point gives me 9.6 kilowatt. And for part B, Q is equal to S into sin phi, which is 12 into 0.6, which gives me 7.2 kVAR. Okay. So from here itself, you can tell the answer 9.6 and 7.2. But what about the current? We will also calculate the current. Okay, that is the peak current. So now you understand that S is equal to P plus JQ, right? P is 9.6 plus J, Q is 7.2, right? So this is our S, right? P plus JQ. So I can write this in polar form also as magnitude and angle, right? So what is the angle? Theta is equal to, or theta is equal to cos inverse 0.8, right? Cos inverse 0.8. So cos inverse 0.8 is 36.87 degrees. So S is given as 12 kVA and angle will be 36.87 degrees. So this is my apparent power. Now the point is apparent power can be written as V into I, So 12 kVA is equal to what? The voltage is given as 120 volts RMS. Therefore, S is V RMS into I RMS, correct? So V RMS into I RMS. Okay, so 12K is 120 volts into I RMS, right? So I RMS is equal to 12K. Oh, there seems to be some problem with my writing. Okay, let me write this again. So S is equal to V into I. So V RMS is 120 into I RMS. So I RMS happens to be 12K by 120, which should give you 100 amperes. This is my I RMS. Therefore, your I peak, this is what they asked, right? So I peak could be I RMS into root 2. So 100 root 2, which would give you 141.42 amperes. Okay. So that is why over here it's 141.42 amperes. The rest, both of these are quite easy, right? S cos phi and S sin phi. Okay. Is this fine till now?
Yes, sir.
Okay, so we'll go ahead then with the next problem. So the next problem is just a second. I'm just opening. So this was question number 10. Okay. So the question number 11 is a bit different, right? So this is based on again RC circuits. All right. So the question is for the first order circuit shown in figure. For the first order circuit shown in figure, assume the switch has been open for a long time and is closed at t equal to 0. calculate V of t at t equal to 0.5 seconds. So they have given a circuit and we need to calculate the voltage. So the circuit is 15 volts, 2 ohms, the capacitor is 1/3 farad. Okay, I am seeing the voltage across this. Okay, this is what I want to find out eventually. There is a switch over here and there is 6 ohm resistor. Okay, so this switch is being closed at t equal to 0. Okay, so before t equal to 0, this switch was open and I am closing the switch at t equal to 0, right? So we have seen in the last week itself for all these kind of problems, just divide the entire problem into intervals, that is t less than 0 and then what happens after the switch closes. Okay, so first let's see the circuit under steady state.
सत्यम का फोन आता है
Sorry,
सत्यम का
hello.
सॉरी सर
Okay, no worries. Okay, so let's first see it under initial condition or under steady state. Right? So let me just redraw the circuit once again. So the circuit was (15 volts), 2 ohms. This is 1/3 farad. You are seeing V over here. There is a switch which was open. This gets closed at t equal to 0. 6 ohms. And then there is another source. 7.5 volts. Okay. So under steady state, that is for t less than 0. Correct. So t less than 0, switch is open. So no need to worry about the right hand part. Your equivalent circuit becomes 15 volts, 2 ohms, 1/3 farad. This is your V. So what would be the voltage under steady state? So what would be the voltage under steady state? That is when t less than 0. There is no resistive element apart from the 2 ohm resistor for voltage division to happen, right? So at infinite time period, right? That is, we are seeing the time from minus infinity to 0. Okay. So infinite time has passed off. So capacitor has reached steady state, which means the capacitor is open. So if the capacitor is open, right? So you understand that the entire input voltage is coming. So V of 0 minus is going to be directly 15 volts, right? Because capacitor is open. Under steady state, capacitor acts as open circuit. Capacitor acts as open circuit, right? Under steady state. So under steady state, capacitor acts as open circuit. So your V of 0 minus is 15 volts, which means that the 1/3 farad capacitor is charged to 15 volts. Okay. So this means that one by 3 farad capacitor is charged to 15 volts. All right. So the 1/3 farad capacitor is charged to 15 volts. This is what has happened under steady state. So just before you close the switch, at t equal to 0, before that the capacitor is charged to 15 volts. Okay. Fine. Now the point is, what happens after the switch closes, right? After the switch closes, you understand that the circuit is going to change, right? The circuit would change and it's going to become something like this. Okay, this is for t more than 0, right? This is for t more than 0. Okay. And we want to see what is the voltage over here. And you know that the capacitor is charged to 15 volts. This is another thing. Capacitor is charged to 15 volts. We have to find out what would be the expression for t first. You understand this, right? So under steady state, we saw what was the voltage across the capacitor. Then after we close the switch, so this is one case, this is one case. Now the next extreme is that I have closed the switch for a very long time. Again, it has reached steady state at t equal to infinity. Right? First is t less than 0. Then just after I close the switch, this is transient period. This is not steady state. This is transient period. Then after the transient settles down, okay, after the transient settles down, you again see that at t equal to infinity. Okay, again steady state. Right? Again in steady state, what happens? The capacitor acts as open circuit, right? So your circuit simplifies 15 volts, 2 ohms. The capacitor is acting as a open circuit, so I'm drawing something like this, right? Capacitor acts as open circuit. This is your V, and switch is closed. You have 6 ohms. And this is 7.5 volts. All right. So what is the voltage V? What is the voltage V? This is the voltage, right? So I can write by nodal analysis V minus 15 by 2 plus V plus 7.5 by 6 equal to 0, right? So I can just solve this. So 3V minus 45 plus V plus 7.5 equal to 0. Therefore, I will get what is V, right? So I am getting V is equal to 9.375 volts. Is this fine? So the capacitor 1/3 farad capacitor will be charged to 9.375 volts at t equal to infinity. So after long time, once the switch is closed, right, at t equal to infinity, So capacitor charges to 9.375 volts. So basically what is happening? You are seeing that initially capacitor was charged to 15 volts and after that the capacitor voltage is falling to 9.375 volts, right? So basically the capacitor voltage starts at 15 volts and from there the capacitor voltage is falling to 9.375 volts. All right. Okay. Capacitor voltage is falling to 9.375 volts. Fine. Is this fine till this point? Okay. So now you can understand that, see, now we can try to understand what is happening with the capacitor, right? So initially it was 15 volts and after that the capacitor voltage gets maintained at 9.375 volts. Okay. So what will be the output voltage of the capacitor if I have to directly write? See, V initial, right? V initial, or we write this as V0 minus, right? It is 15 volts. And V final, or we write this as V infinity 9.375 volts. Okay. And if you draw this, I will just draw the circuit once again for our own reference. So this is 15 volts, 2 ohms, 1/3 farad, V. This is 6 ohms and all right. Okay. So in that case, you understand initially the capacitor started off with 15 volts. Finally, it is going to rest at 9.375, right? So finally, it's going to come to 9.375, which means that my capacitor voltage, right? My capacitor voltage, if I plot VC, right? VC against time, you can understand that the capacitor voltage at t equal to 0, right? It is starting at 15 volts and then it will fall, it will fall, it will fall. It will finally settle at 9.375 volts. Okay. The question is find out what is V at 0.5 seconds. Are you able to visualize using this graph? Is this understood? This graph, are you able to understand? So nothing, we have basically we have analyzed it under steady state when the switch was not on and when the switch was on. That's it. Under steady state, before switch is turning on, what is the voltage across capacitor? And after the switch turned on, right, under steady state, what is the voltage across capacitor? That is V for t less than 0 and V for t equal to infinity. So from this we understood that whatever is happening, the voltage is just changing from 15 volts to 9.375. Basically my capacitor is discharging. Okay. Do you understand till this point? Any doubts? till this point? Fine, right? Okay. So now the point is, how do we represent this, right? So graphically speaking, also, I think this is very easy for you. Graphically, if I tell, right? So how can I write this point? This point can be written as 9.375 plus something, right? Sorry. 9.375 plus something. Okay. So I can write VC of T is 9.375, right? And then it is falling from where? It is falling from 15 and it is falling to 9.375, right? Into e power minus t by tau. Agree with this? Is it agreeable? This point can be written as 9.375 plus there is some component. We just need to find out this particular component, right? So what is this? My voltage is falling from 15 to 9.375. 15 minus 9.375 into e power minus t by tau, right? So this is basically 9.375 plus 15 minus 9.375 is 5.625 e power minus t by tau. Till this point, is it fine?
Yes.
Okay, great. So now what is tau? Tau is equal to R into C, right? R equivalent into C. So C they have given us 1.1/3 farad. This is fine. What about our R equivalent? This is the circuit, right? This is the circuit. Here I have to find out the R equivalent looking from this perspective, right? So if I have to find out R equivalent, what will I do? I will disable the voltage sources, right? That is short the voltage source, open the current source. So let's do the same thing. Short the voltage source, 9.5 shorted. Then 2 ohm is there, right? And there is a capacitor over here. And that is 6 ohm. Again, 7.5 volts is shorted. Okay. Just we have shorted voltage sources. And now I am looking from this perspective, right? Looking from here. Let me erase this. Okay. Now I'm looking from here. Please pay attention to this problem, okay? I'm looking from here, right? So from here, if I see, right, I'm seeing from this point, you keep your eyes over here. From here, you're trying to look. So what will be your R equivalent? From the middle point, what will be your R equivalent?
2 is in parallel with 6, right?
Exactly. So 6 and 2 are
1.5
in
ohm, sir.
parallel. It is
1.5 ohm.
1.5 ohm. Correct. So, but the point is, main thing is that 2 and 6 are in parallel. Please remember, don't just think that, okay, 2 and 6 are in series. If you see from here, 2 and 6 are in series. But make sure you are looking from the right position. That is, you should look from where the capacitor is there, right? So from here, if you see, 2 and 6 are in parallel, which is 1.5 ohm. Therefore, tau is R into C, which is 1.5 into capacitor is 1/3, right? So 1.5 is 3/2 into 1/3, which
0.5.
is
0.5.
1/2 seconds. Correct. Okay. So from here, I can substitute back to VC. So VC of T is going to be 9.375 plus 5.625 into e power minus t by 1/2, right? I can write this as e power minus 2t. Okay, this is the capacitor voltage. Once we know what is the capacitor voltage, we see at 0.5 seconds is going to be 9.375 plus 5.625 into e power minus 2 into 0.5. Okay, so just 5.625 plus 9.375. It is coming around 11.444 volts. Okay, this is the answer. Okay. See, look at this question. I'll just recap this question and we will conclude for the day. Okay, it's almost 8 o'clock. So what did they give? They have given a circuit over here, first order circuit, but point is that there are two voltage sources, 15 volts and 7.5 volt source. So till now, whatever problem we have seen, it is like either voltage source will get connected after the switch opens or closes, or either voltage source will get disconnected. But over here you see there is one voltage source before the switch is closing, and there are two voltage sources after the switch is closing. Okay, that's why this is a tricky problem. So first thumb rule for all of these type of questions: under steady state, find out. Okay, under steady state, that is t less than 0, what happens? And t equal to infinity, what happens? Two extremes, before switch is closing and after switch is closing. So both extremes, right? T less than 0 and t equal to infinity. You see what happens. That is what we did. That is t less than 0, switch is open. So the voltage is 15 volts directly. This is the capacitor voltage. And at t equal to infinity, right? That is the other steady state. So we found out by nodal analysis what is the voltage across a capacitor, 9.375. So we are telling that initially the the capacitor voltage before the switch is turning on is 15 volt. From there it is going to 9.375. So basically I was at 15 volts at t equal to 0, and then from 15 volts I am discharging to 9.375, and it will remain 9.375 ever after at t equal to infinity. Okay, got it, right? So two extremes we have found out, that is steady state before t equal to 0 and steady state at t equal to infinity. Okay, we have found both of these. Now that we have this, just think of a plot. Okay, don't mug up this formula V infinity, V 0 minus and all. You think analytically. 15 volts was there initially. From there it's discharging to 9.375, and it would obviously be a exponential discharge. So just draw the graph. You see that initially there is a DC shift of 9.375. So this point at 0.5 seconds, what will be the voltage? It will be 9.375 plus something. So 9.375, right? 9.375 plus whatever is the difference, 15 minus 9.375 into e power minus t by tau. Okay, this is the voltage across the capacitor. Now the point is, what about tau? For tau, you should look from the perspective of where the capacitor was there. Don't look from here or here. Okay, you should look from the perspective of where the capacitor is over here. Okay. So from here you see 6 and 2 are in parallel. Therefore tau is 1 by 2 seconds. And after that you will get what is the capacitor voltage. Okay. Is this question understood by everyone? Like, are you able to understand and this expression, how we are able to write? Okay, don't mug up the formula. Okay, but are you understanding this? Are you able to visualize? I think with this graph it should be simpler. Is this fine?
Yes, sir. It is. It is okay, sir.
Okay, great. Would you like to solve like one more such problem in the next class before we take problems for the next class? Like, do we need to bring one more problem, or this one problem itself is enough?
It's okay, sir. We can this problem is also well explained. So if we practice this one or two times, we can practice it. Then we can do it, sir. I guess.
Right. Okay. Okay. So then, okay, we will conclude over here. And thanks for attending, everyone. We will meet again in the next class. Okay.
Hello, sir. Sir, one
Yeah,
slight request, sir. Sir, actually,
Yeah,
while
okay.
joining, I missed the initial part of the session today, sir. So can you just
Okay.
upload this YouTube video today with the slides so that I can do it tonight?
Yeah, okay, sure. I will do it.
Yes, sir. Thank you. Thank you very much, sir.
Okay, okay.